Welcome to The Explainer. Today, we're diving into the origin story of an entire field of engineering. It's the science behind the tiny, complex devices that pretty much power our modern world. We're talking everything from the phone in your pocket to the airbag in your car. So, let's get into how it all began. So, over 60 years ago, the brilliant physicist Richard Feynman gave this talk where he threw out a wild idea that we could manipulate matter atom by atom. He famously said, there really is plenty of room at the bottom. But, it's one thing to point the way, it's another thing entirely to actually walk the path. So how did engineers go about claiming all that room at the bottom? How did they build the tools and, more importantly, the knowledge to create on a scale we can't even see?
In the very beginning, trying to build these miniature systems was a lot like exploring a brand new continent. But imagine doing it with no map, no compass. Heck, you don't even have a common language with the other explorers. Researchers knew what they wanted to build, but nobody had written the rulebook on how to actually do it. So what even is a microsystem exactly? We're not just talking about a computer chip here. No, a microsystem is a complete tiny machine. It's got the senses, that's the sensors, and the muscles, those are the actuators that make things happen, and of course the brain, the electronics that tie it all together, all of it on one tiny little platform. The key is you're shrinking an entire functional device, not just one little part.
And this really gets to the heart of the problem back then. You had this totally divided world. On one side, you had electrical engineers who were wizards with circuits. On the other, mechanical engineers who knew all about structures and forces. But they were in completely different worlds. Their knowledge was scattered all over the place. The goal, the big dream, was to tear down those walls, to create this new kind of engineer who could speak all of those languages fluently.
All right, so who were these brave souls? Who were the first people to dive into this uncharted territory? Let's talk about the pioneers who did all the messy, difficult, and totally groundbreaking work. The very first explorers, they pretty much all came from one place: electrical engineering. These were the folks who were experts at making computer chips. And they thought, hey, maybe we can use the same tricks to build tiny machines. The big problem, though, a computer chip just sits there. It doesn't have any moving parts. These new things, they were meant to move. And you can't overstate how massive their struggle was. These electrical engineers basically had to become mechanical engineers overnight. They had to figure out things like stress and strain on beams so small you couldn't see them. They had to learn fluid dynamics, how liquids behave in tiny little channels. They had to become chemists and material scientists, all at the same time. And all of this was done by digging through obscure academic papers. Because remember, there were no guidebooks. They were literally writing the book as they went along. For decades, this was all just a really niche academic thing, kind of quirky. But then a few things happened in quick succession that made this little field just explode. It had finally reached critical mass. You can kind of see how the momentum built up over the years. It started out pretty quietly back in the 60s with the very first integrated sensors coming out of labs. But then, in the late 70s, the auto industry came along and said, hey, we need a ton of these little pressure sensors. And that's what really kicked off high-volume production. Fast forward to the mid-80s, and we get some new fabrication tricks, and the field even gets its famous name, MEMS, for micro-electromechanical systems. But the real game changer? The 90s. That's when government agencies like DARPA just poured money into this, and it sparked this incredible wave of commercialization. And this is why it all matters to you and me. That boom in the 90s, it led to tech you probably use every single day without even thinking about it. You know the super precise nozzles in your inkjet printer? That's a microsystem. The accelerometer in your car that knows to deploy the airbag in a crash? That's a microsystem. Digital movie projectors, medical DNA analyzers, infrared cameras. All of it was born out of this revolution. Okay, so the technology is booming, the applications are popping up everywhere, but there was still one giant hurdle left. How do you keep a revolution going if you can't train any new revolutionaries? And this was the real sticking point. The field was real, the industry was real, but the education system just hadn't caught up. You couldn't just major in microsystems engineering. All that knowledge was still fragmented, and the original pioneers were getting genuinely worried about how they were going to pass the torch. The solution was laid out perfectly by one of the field's leaders, a guy named Kunzel Wise. He basically said, look, if we formally bring all this stuff together, it's going to do two incredible things.
One, it'll speed up the field's growth. And two, and this is the big one, it will finally give rise to this new kind of person we've been dreaming of, the microsystems engineer.
So, you know what's funny? The climax of this whole origin story isn't some crazy new invention. It's an act of organization. It's that moment when universities finally started offering unified courses and professors began writing the very first textbooks. Those were the maps, right? The maps that the next generation of explorers could finally use. They took all that hard-won, scattered knowledge and finally turned it into a formal discipline.
So it went from the scattered collection of curious engineers to a massive global industry. Microsystems have totally changed our world. But, the story is far from over.
I mean, think about it. That first generation took us from a wild idea to the devices we literally can't live without today. So that makes you wonder, right? With these amazing tools and all this unified knowledge, what problems is the next generation going to solve? What are they going to build?
And that really is the true legacy of all their work. The quote says it all. Finding solutions to many of today's problems will require microsystems engineers to develop devices that we cannot yet imagine at a scale that we cannot see. That first generation, they gave us the language and the tools to build the future, one tiny, absolutely incredible machine at a time.